So in this video I wanted to talk a little about VEX and my kind of thought process when working with it, because for me as someone with no programming background it's kind of hard to, it is a little intimidating I would say, because in tutorials it's kind of easy for the beginner tutorials, but once you start to sit down and say okay I want to move around some values around, and there's also this disconnect between you and the things that you want to do in VEX. So what we're gonna do in this tutorial video, I won't even call it tutorial, just messing around with VEX. We're just gonna play around with some values, move them around between the attributes and play around with it, and I hope we learn something from it, because I know I did. So let's get to it. So to start with, let's create a box. In the box I would assume that you know something about VEX, because obviously this isn't really the beginning tutorial about what's the attributes and all of that, but this is more about how can we move around values and things like that. And you can see that already when we put down a box on a point, there's actually attributes, which is position. What's cool about this, of course, let's play around with the color also. So what I liked about this setup is because there's already two values that we can move around and copy between them. So, and they are all both vectors with three values, so we can both play around with these values. And if you take a look at something like, also in the color node, there's some randomness on it, like that. And what I like to do is actually think about how is this created inside VEX, because in here there's just a bounding box and there's a selection, and what I want to do is just recreate these kind of colors with only the VEX, and I think that's a really great way to start with the VEX and learn how it works and how we can move around these kind of values, color and position values. So let's take a look at that. First thing what I want to do is actually create this box, actually convert this box into the point. So what you can do is just write a point. There's option point from volume. What it's going to do is just create inside this box, there's actually going to be now points inside it, like that. So now we can actually see, and now we can just color the points. So first thing what I will do is just create it in one color. Let's say I want them to be red. And now let's put down a wrangle node, which I'm sure you have seen in many tutorials. And so one thing to note that we are not actually writing VEX, we are writing VEX expressions, basically more user-friendly way of writing VEX and more easier. So what we want to do is, first of all, let's go to the help and go to the VEX functions page. These are basically all the functions that we can manipulate inside VEX, and for our geometry, not all of these are for geometry, but if you go to the geometry section, there are many things that we can do. If you take a look at these, add primitives to geometry, which is end primitives, return number of primitives in geometry. So basically this is where we go to when we want to do something specific with our geometry. The first big tip what I can do is, what I can give is actually the reading the functions and how to write them. So if you go in here and let's say endpoints, so if you take a look at this, it tells the number of points in the input or geometry file. You can see it's very simple. VEX function, it basically says endpoints, and then you have to write in what kind of geometry that it points to. So the first thing is basically, if you go around with these, you can see it's basically going to show what kind of information it asks. So geometry, basically saying where the geometry is located. Int basically asks for int number, so that's a whole number. And all of these are basically the same. It's basically going to say what kind of information it asks for. So that's very important too. It's kind of a pretty obvious thing, but if you really notice it and remember it, that it's actually very useful to kind of think about what kind of information it asks and something like that. So what I'm going to do is actually use these endpoints. So let's find it back. So endpoints is somewhere in here. This is very simple and very useful. So if you go to the attribute wrangle, and let's say endpoints, and then you write in the brackets, and you can see it automatically becomes kind of like a teal. I don't really know what's kind of in English. So, and you can see in help it actually says where the geometry is located. So in here it basically is connected to our wrangle node, and for anything that's inside the first point of the wrangle node, it's basically going to be just a 0. Close it down with this, and that's it. You can see it hasn't given any errors, but one thing is it's not actually being displayed anywhere. So what you can do is actually write it inside the attribute. So let's just write an int attribute test equals endpoints. That's it. Like you see, we have now our endpoints, which is, I think here, returns the number of points in the input geometry file. So it says that we have 1331 points inside our geometry. And that's true. If you go back to the very end, there's a 1330. And one thing to note is that Houdini starts counting at 0, and so if you add one more, that's going to be 1331. Very often you will see in functions that you're going to have to specify geometry that you want to run over any function, VEX function. So one thing to know is where do we get this 0 actually. So there's actually kind of a hint inside here. If you go inside here, you see that actually the first point is actually the geometry. So if you put down disconnect to the second one, actually we don't get any geometry like that. So the first one is always going to be actual geometry that's going to process and put the points over it. But what we can do is, and let's say with this you would think that okay, 1 is actually the second input. So if you delete this one and connect to the second one, you can see we have nothing because there's actually no geometry inside the wrangle node. So, but if we connect these both to the 1 and 2, and let's say now we put down 1, you can see it still works. If you put down 2, nothing. But if you connect this to the second one, you can see it's back on. And same with the third one. You see, it's basically geometry is going to always be the first one, and we can still work in the first one over this geometry. But let's say we can actually put down a sphere like that. Let's put down to the polygons. What we can actually do is connect it to the second one, and now write in a 2, 1. So the second one is 1. You see, now it's actually gonna give us the point number of our sphere. We can go even one step further. Just delete this one, and we can actually reference it by its place inside our network. So let's say we have this sphere and it's not connected. What we can use instead of numbers, we can actually use op operation. So let's put it in quotes. So let's say op colon dot slash, and just like in Windows or operating system, it basically says dot slash basically go outside this node. We are inside our GO2. Let's say over to this sphere, and all we have to do is now write in sphere 1. So basically this op is now pointing to the sphere. You can see it already works. It's basically saying 42. We have not even connected it, and what's cool about this, we can create another geo in here. Let's say I just put down a simple box. Let's go back to the geo1, geo2, and now what we can do is actually point it to that box even if it's not inside our geo2. So if you think about it, we have to go outside again to the obj level. So now we are at the obj, we are 2 steps outside this one. So we are outside the node and now in our obj. And now we want to do is that was geo3. Now we want to box 1 like that. Now you can see it's 8. That's 8 points. And if you want to go one step ahead, we can actually read values from files on our computer. So what I'm going to do is put down a file. I'm going to go to here, and I know that on the desktop I actually have some of the I have this promo FBX file, and so what I can do is actually reference the path to this file inside our attribute wrangle, where it asks for geometry. If you take a look at this geometry, so if I paste this, then I know that file name is promo.fbx. You can see it reads that amount of points inside our file, even though we haven't even opened it inside Houdini. It basically goes and takes a look at this file and reads amount of points. To make sure, we can take these points and go here and open up inside Houdini. So there it is. This is basically the ZBrush weapon model, and if you take a look at, so 48,666 and plus 1, that's the amount of points it has. So that's a cool thing you could do. It's when it asks for geometry, there's many ways you can go with this. So now let's take a look at something else. Another simple concept inside VEX is basically that whenever you put down attribute wrangle node, you can see there's actually option for run over points, primitives, vertices, numbers. Let's just make it easier, just go to the points. You can see that this function is actually going to go through every point inside our geometry like that. So you can see it's actually all the same in all of the points inside our geometry. So what I want to do is pay attention to the using VEX expressions. There are actually some of the variables that are global. If you think about it, there's a very nice explanation. Most snippets involve looping over all the points and primitives in a geometry. You can see these are kind of like you write them at just like the attribute, but they are already have values in them. You can take a look at this, basically saying that how many primitives or how many points or how many vertices are inside the geometry that you want to loop over it. That can be insanely powerful if you think about it. So let's say you want to run over this, over all the points, but add 1 to each point. So go to this. There's actually function variable ptnum, the point number of the current point. So let's do 2 slashes to disable this one, and let's create a new integer attribute test2. That's going to be at ptnum plus 1. Another thing to keep in mind that there's actually in Houdini help there's a list of the known attributes with a known type. So basically this is so VEX type is basically whether it's a vector, there's a 3 numbers in it, or whether it's int, string, or something like that. So let's say we know that CD consists of 3 values, so that's a float. That's a vector value, I'm sorry. So that means usually if you want to declare a vector value, you have to be at this is vector. And then with the curly brackets, you have to give it each one of these its own value, like that. So then if we run it over the points, you can see we have our vector values 1, 3, and 5. With these known values, we do not have to address whether it's a vector, whether it's a float, int, or string, so because in VEX it's gonna already know what it is. So let's say we have CD, we not have to write v at CD equals 0 and then curly brackets 0, 0, 0. We can, and it's gonna still work, but whether we use it or no, do not, it's gonna be the same result. So it's gonna just save our time because these are the known types for the VEX nodes, so you don't have to address what type it is. One thing you quickly start to understand that these are all considered as a variable. So I have attribute variable, which is here 34. I have printed it out as a attribute. I also have just simple variables that I have made inside this attribute wrangle node, and these are just considered as a variables and they do not print out in here, but I can always reference them inside this attribute wrangle node. Let's say I want this attribute to be the same as my value 3. So all I have to do is I can copy and then I can just say that it equals my value 3. You can see now we have basically created a variable that's not an attribute and copied it to the attribute that is copy it to the points. And what we can do is also, let's say, plus add ptnum. See, we are now adding one of every, so basically what we're doing, we know that this code is running over every point. And you can see that add ptnum is basically the number of points, then the point number that this code is running over. So let's say 325, we are so basically adding 67 plus 325, that's going to be 392. So we're just taking this point value and adding to this, so that's why we have different numbers. The next obvious question is, of course, how can we get out of this, out of the attributes values inside our wrangle node? So for that we have to go back to our help, and there's actually, if you write in point, there's actually a point VEX function. So there's a, for every point there's a vertex, there's a primitive, and also the detail, the same ones. So basically this is, all of these do is the read value of the detail attribute from the geometry. So let's say we need to get the position for the fifth x position for the fifth point. So we know it's minus 0.5. So in this it's very easy to understand. So we go to the point, because that's a point class. For us to get these numbers, for us to get this value, fifth point's x value, all you have to do is follow this blueprint. So let's say, so let's follow it point, then it asks for the geometry. So we know that we have connected to the first point of our attribute wrangle node, so let's point 0, and then it asks for attribute name. So for us to know how exactly we have to write it, let's go to the very bottom of it. There's actually examples. You can see that it's UV, P, and CD. It's actually do not need to write add, because it's a, but it does has to be in a quote. So we just have to, in quotes, write the attribute name. So let's not use add, even though we might think we need to. So in the quotes, let's write P, and then all we have to do is write the points number that we want to get value of. So that's going to be 5. And then close it with semicolon, and that's it. So we have created this value, but you can see it's actually showing the error. Even though we have created this value, there's nothing actually that holds this value, so that's why it's giving us error. And one thing to remember, that even though you might think that usually you can actually address the specific x, y, or z in vectors or in arrays or whatever, you actually cannot do with this point command. So let's say I want to, you can usually do it like that. So I want to only get the x value of the p. It actually will not work like that. You actually can just the whole vector, so that's going to be 3 numbers, 3 values. So we know that what we want to do is output a vector. So let's create a vector variable that's going to hold this value. Vector, this is my value, equals points. You know that error is gone, but before that you can see that since it's not an attribute, there's actually nothing that we can check that it's actually working. So what you can do is actually print a value on our console. So that's going to be printf, and in the brackets all we have to do is in the quotes write down a percentage and d, and then after that with the commas write the variable that you want to output on a console. That's going to be that, and close it with a semicolon like that. Let's clear it out. You can see that we have now outputted the value of the fifth one, of the fifth point. But then, since we wanted only the x value, what we can do is just create another variable. So we know that now it's going to be just a float value of 1. So what I'm going to do is float, my float equals, and now this is going to work. This is my value dot x, like that. And now if I want to output out this is my float, you can see we are now only outputting one number. you can either X, Y, or Z or RGB. So it's basically the same thing. R, G, and V. So that's going to be whether it's a 1, 2, or 3 on a vector, like that. So that's very useful to know. One last thing about vector that's not super obvious at the start is that, let's say we create a vector attribute, let's call it test equals, you do in a documentation say that you have to use the curly brackets. But let's say we have created a float value equals, let's try to see. So we actually, with the rules that we have taught, you would think that we can just reference this inside our attribute, or whether it's a variable without a v, but actually we cannot. For this to actually translate into this, you actually have to use the set function. So once we have set made, we can actually now reference any of the variables inside here, or anything that we write, or even the functions that data type is accepted. So let's say like that, then end the colon like that. See, now it's actually working, and you can change the test2 and its update. And of course we can also do some divided by 4 and it's still going to work. So that's one thing, that with the curly brackets you can't really get the other values from other variables. So what you need to do is use the set function. And you take a look at the help, you can see that it's basically the same with the vectors, with any vector matrices and something like that. So that's very useful to know. And with this knowledge, let's go into the second part of the video where we actually do some point manipulation. Now let's take a look at this setup that we have. Let's say take a look at this color, and you can, if you press on this, you can see there's actually RGB channels, the same ones that we have in attributes. You can see that we have R at the 1 and green and blue channel at 0. So we want to leave it at that. And what we want to do is actually randomize the red channel without leaving these at the 0. So how can we do that? So we can put it on random, but that's going to be randomize all of the channels. So let's say we don't want to do that. So what we can do is use the rand function. So if you write in the rand, which is basically very beginner friendly VEX function, which is basically saying it's going to create a random number between 0 and 1. What's great about this, because if you take a look at this, all of the RGB values are between 0 and 1. So we don't want to go like a 2, because then you see that it actually messes up all the colors. So what we want to do is between 0 and 1 values. So if I go in here, we just read it out. So all we have to do is put down a rand and then some sort of float seed. So let's go. Let's just put down a rand. So all we have to do is, before that, of course, we have to actually what we want to change. So we want to change the red channel. So add CD, and you know it's a red, so dot R. So this is basically going to address that we want to change this channel. Then just put down rand, and then let's some sort of seed like that. Then close it down. You can see we have value, random value. But of course this is not very useful for us, because first of all every value is the same, and also we cannot very easily change the values, so we have to manually do it. What's cool about this is that you can actually create the channels on the fly in this attribute wrangle node. For that, all we have to do is ch, and after the ch is the channel type we want to do. So we want to float, so gf, and then all we have to do is write the name of the channel, my random, like that, and that's it. We have created our randomization, and maybe just place on this. You can see it actually creates the channel. Now if we take a look, we can actually go around and randomize every channel. But you can see the one last problem is that we actually do not have different values for all our points. Let's say what we want to actually randomize our points, each one of them. And of course, that's where it comes in our at ptnum. So let's say we have to need some randomizer that's unique to every one of these points. So what we can do there, let's say we have randomized, and this randomizes this, and all we have to do is it multiply by the at ptnum, like that. So what we are doing, we know that this command is running over every point and doing this command. So we are basically this multiplying by out ptnum is going to give us a random number between 1 and 0. So this really doesn't matter how big of a points we are putting inside these brackets, because at the end of the day you're going to spit out 0 to 1 value. One thing I noticed that you can't really see what I have because I have this zoomed in. So all I did after I created this channel, all I did is press on this button, create spare parameter for each unique call. Then it's basically gonna pop up at the bottom of the randomizer. So whenever I create channel, I press on this and it's gonna create the channel. So back to the zoomed in view. Now let's say we have lots of black dots. Let's say we do not want any, we want to randomize not the 1 and 0 to 1 range. So what we can do is actually limit the amount of randomization, what kind of numbers we pick up in our red channel. So what we can do is, let's take a look at this VEX function, which is VEX fit function, which is basically take the value range and then shifts it to the new range that we give it to it. So it's pretty easy. So basically we want to give the value, the min and max of our values that we're gonna give. So that will be 0 and 1, because we are giving the full range of the red channel, which is 0 and 1. And then we want to shift it to the new values. To start writing this fit function, what we can do is one thing that's kind of pretty obvious, but still worth to point out, that we can actually write in other functions inside other functions. So let's say our fit function asks for a value, and that's a float up in here. So if you think about it, our randomizer is actual float number, and we can basically write rand inside the first part of the fit function and it's still going to work. Let's start writing this function. So first of all, we want to address which kind of channel, which is cd.r equals fit. Next, inner brackets, let's write rand. Now a new brackets, and remember in the first one we reference it to the channel. So what we can do is actually use the same channel. What I'm going to do is just copy this channel like that. Then let's close the brackets. Now the comma to start the new one. So now what we want to float on min and on max. So this is basically the range that is gonna give this randomization is gonna give. So we know it's our rand function gives from 0 to 1. So basically the min is 0 and the max is 1. Now all we have to do is reference new channels that we want to shift it to. And all we have to do is create a new channel. So for the last two, I'm gonna copy this one. I'm gonna just add new names. So it's gonna be my min, and then the brackets close off, comma, and then let's copy it again, and my max. Then close it down with semicolon, and that's it. See, we have exclamation mark. Let's close out this first. First of all, let's take a look where we have done wrong. So you can see that we have not closed off our fit function actually, because we closed off these. If you press on brackets, you can actually see it's gonna mark where they start and where they end. So we need another bracket at the end, like that. You can see we are still getting errors, and first of all I did the number one fail. I didn't actually add from the attribute, and also I didn't close off one of the brackets. So let's take a look. So we started the fit. We know that it ends with the the brackets too. Then we start the rand, but we do not close off rand, we only close the channel name. So we have another one in here, like that. Now it works. Now let's press on spare parameter box, and now we have two parameter boxes, and if you change them, you can see that we can easily move around with them, and change the actual values that we can randomize. And this is the randomization, and you see that all of our numbers are actually the same. So now you have seen the channels. What I'm going to do is actually turn off the zoom in view, like that. Forgot about this. I kind of forgot about it. So you can see we are randomizing, and we can say where my min and max is. What's the color range for the red? And if you want to get the randomization of every point, remember that we can use the number of every point. So for the randomization in a rand, what we want to do is this channel that we randomize, we want to multiply with at pt num. So this is basically going to multiply by the point value and gonna give us random numbers like that. But one thing to note is that our first one never changes. You can see that it's because of its value is actually 0. If you think about 0 multiplied by any value, it's going to be 0. So what we can do is actually at pt num, we can add actually 1. And of course we have to put it inside the brackets, because just like in school, order of operation, the multiply is first and only then the adding. So put in brackets. So now we are actually randomizing also the first one. You see the 0 one also changing values. We can change how many, what's the range of it. So let's say we don't want to totally black ones like that, but I want everyone else like that. And now let's actually array the R. You can see that actually now what's going on is basically we're writing the same value inside all the 3 channels. So you can basically getting it basically black and white dots. So but how can we clamp down the value for our colors but randomize them so we can make them more dim or more bright, but still randomize it with all the 3 channels? Well, what we could do is actually use the same channels for all 3 of them, but we need to randomize each one of these, each one of the randomization channels. So you can see now it's basically giving the same number for all of them. What we can do is actually copy this, and then let's address it by each channel: R, G, and B. So right now nothing really happened because it's the same, because it's randomizing the same thing. So basically the same values, even though they maybe not be at the same in the same function, it's gonna be randomized exactly the same. What we need to is actually randomize inside each of these. So in Houdini, very often it's basically said that you can basically add anything. If you think about it, you just need to randomize it a little bit differently than all the other channels. So what I'm going to do is just add 10 and add 100 to these 2 channels at the end. And now you can see we are actually randomizing different numbers for every channel for every point. And you can see that still our channel is still working. We can randomize it, make them brighter, or use the full spectrum of our color like that. This video is already too long, so let's just do one more thing. One more cool thing they can do with this VEX and with fit function. You can actually color this cube based on its positions. You take a look at this. There's actually option for the bounding box. You can see whenever you make it bigger, it basically stretches out all of the color range for this box. So how can we do that? So if you take a look at this wrangle, the first thing we can do is basically add CD equals add P. So we are basically giving colors to the positions to its color. So basically, okay, I screwed that up. So they're doing basically copying the positions to the color attribute. You can see the colors are very different from our bounding box in the color SOP. Because if you take a look at this, there's actually, this box is not located exactly because there's minus and plus values. If you take a look at the color, there's really its values from 0 to 1. Let's say we make it box 1 1 1, and now we put down a match size, and let's put it to the min so that it's actually located only in a plus axis in all of the three axes. And if you take a look at this attribute, you can see it's exactly the same because now the color is actually exactly the same. It's in a positive axis. All of the three axes are positive, and it's giving the same. But of course, once we have stretched it out, we're actually getting the wrong colorization. Now if you compare, you can see the colors are getting not right values because now we are getting more than one. What we can do is actually use the same fit function and actually move these vectors. You can see in the function there's actually the same thing with the floats and actually vectors. What you have to do is move these vectors to the 0 to 1 range. But there's one problem, that because these vectors can be different. So let's say we move this box around. You can see that positions for our points actually move around. For the box, it's good because all the points, if you turn on the point visualization, so basically the point 1 is going to be in here, so basically at the bottom, and the very last point, which is like in here, 939. So this is basically the last point. Basically this covers all of the possible ground for our points. First thing we have to do is actually get the vector values for our max and min. We know that we can do it with point function. So let's create a vector, my max vector, and it's going to be, so let's say point. Now I want to get the point value of the last one. What's good about this, we can actually use, let's take a look at the help, and then for point we have to geometry, so we know that 0. Then we want to what kind of position, what attribute we want to position, and then all we have to do is which point. So for the max, we know it's the very last point in our geometry, because that's how our geometry works, because it's all very nicely laid down with the sequential order. So all we have to do is say that we want to, the point is going to be at ptnum minus 1, like that. Then close it down like that. So why minus 1? That's because the total number of points is actually 9350, because it starts count with 0. So now we just want to minus 1 for it to count as the last point. Now let's copy this and let's create another vector that's going to be our min value. All we have to do is change the min, points the same, we know the exact point number, and that's a 0. We want the 0, the very first point, and that's it. And you can see that these are actually created as attributes, and we do not need that. We can basically just create them as variables, because we just need to reference them inside our fit function. Now we can actually start writing our fit function. Now all we have to do is create our fit function. So what we want to do is create the CD, add CD equals, so now we want to fit. So in our fit, let's go back and let's take a look at our fit back. So what we have to do is, if we give all the vector values, it's going to work with the vector. It's going to give for every point its own value now. So for now we want to give what we want to value that is gonna run over. So we want to add p. Let's say we want our position to be given as a normalization, as a thing that we're gonna shift to. So basically the values that we are going to shift to. So these are the p. Then all we have to do is address our min and max vectors. So first one is min, so min and max. And now all we have to do is give the range. So from to what the range to give it. So for the min is 0, so the min is going to be 0. For max is going to be 1. Then close it down. You can see the result here. Obviously we did something wrong here. Let's disable this call node. So first of all, we didn't write CD right. It's actually CD, not CC. You can see we're not getting actually correct ranges because actually I did wrong with at ptnum. Ptnum is actually going to the current number of points. So that's actually not. What we're going to do is actually overall point number. So as you go in reference, there's actually option for the at num pt, the total number of points in the current geometry. So we want to use this one, not at ptnum, because that ptnum is actually basically this different number for every point in geometry, not just one constant number, which is number of points in geometry. So let's just copy this one, and of course we still want to subtract 1 from it, because it's gonna give us value that does not exist, and it's gonna give us a 0. But right now you can see it's actually working. So if we go in here and go enable the color swap, it's basically the same thing. You can see we have shifted our values. If you disable, it still works. So, and of course if we go here and change them in here, all the values are being shifted dynamically across all of the box with this fit function. That's it for this video. I hope you enjoyed my ramblings. So maybe I do want to make more VEX videos, so maybe something more in depth and something more to the point. This is just me screwing around with it, but I had lots of fun. I think with this kind of methods you can really learn very basics very well about the VEX. So see you next time.